Hello everyone, welcome to Computer Science 350, lecture number 2. Okay, today we're gonna start learning the definitions, everything we need to know before we get to any theorems, and we'll start learning theory a bit later. But first off, we need to define a couple of things. Okay, so let's get to that. Just as a reminder, again, what I want you to do, I want you to take notes while you're watching this lecture. And then take a photo of those notes and submit them by the end of the day, by the end of Thursday, before Friday, to Blackboard. Okay. What else? On Monday, we're going to have the first homework. It will be due on like at 6:30, 6 p.m. as usual. Okay. Perfect. Okay, let's start with the definitions. I'll be writing everything on the Google document. However, I will not be making those notes available to you because I definitely want you to take notes yourself. Okay, let me select the font 30. Yeah, something like this. Okay, so let's start with the definitions. The first definition, which we need to learn, is set. Okay, so I usually ask students, hold on, number 1. Okay, set. Okay, what is a set? Usually students say something like, it's like set is a set of something, like a set of chairs, set of cameras, set of books, set of classes, right? So, but saying set is a set of something is not the best way. Okay, so set technically, or at least in this class, and I think actually this term appears in maths and calculus as well, but for our class, for the purpose of this class, Computer Science 350, a set will be a group of objects represented as a unit, okay, in any order. So a group of objects of the same kind represented as a unit in any order. So it's a very important thing to notice that the order does not matter. For example, if I have a set of numbers A, B, C, D, letters, right? Then the set of letters, I don't know, D, C, B, A will be exactly the same thing because the order doesn't matter. It will basically represent exactly the same set. As an example, so we usually say, kind of denote sets using the capital S letter. So we'd say, for example, S1, and then using curly braces would basically explain what the set contains. For example, S1 equals 4, 7, 8, 12. Okay, so in this case, set number 1, so S1, contains 4 numbers, right? 4, 7, 8, 12. Okay, and S2, being, I don't know, 12, 7, 8, 4, okay, and then we can kind of conclude that S1 is equal to S2, which means S1 and S2 are exactly the same things. Hope it makes sense. Okay, now what is an element? An element or a member, would be any object of a set. Okay, for example, in our case, 7, right? So what is 7? Like one of the elements of the set S1 would be 7. 12 would be another element. 8 would be another element of S2, right? Or element of S1. Okay, so it's kind of similar to an array. An array would be a set of numbers, and each one of the elements would be an element of that set, an element of the array. Membership. Okay, so the way we explain membership is this special symbol, and that's actually, hold on, that's basically how we actually denote that, like this symbol here. Hold on. Yep. Yes. So that symbol denotes membership. Something is a member of something else. Something belongs to something else. So for example, yeah, by the way, so that symbol means belongs to, right? And the opposite symbol, which will be this, hold on, It gotta exist. Hold on. So that's belongs to, and then if we cross it this way, yeah, it'll be this. Okay, so this symbol means belongs to, this symbol means does not belong to, which means, like, for example, if I say example grazie, for example, I will say 7 belongs to, right, S1. Okay, that means 7 as a number is contained within S1, or 7 is one of the members of the set S1. And for example, I can say that, let's say 3 does not belong to S2. Okay, so 3 is not a member of S2. Okay, hope it makes sense. Now let's talk about multiset or multi-set. By the way, when we're talking about the set, it's very important to note another thing is that without any duplicates. Okay, so a set cannot contain any duplicates. A multi-set can. So multi-set would be, for example, S3, and it can have like 4, 7, 7, 8, 21, 81, 81, 81, right? So that'll be multi-set. Okay, hope it makes sense. Now let's talk about another thing, which is called infinite set. Okay, so any set can be either finite or infinite. If people just say just a set, that means it's not really clear if it's finite or infinite. But infinite set, you can kind of guess what that means. That means it is a set, which means a group of objects represented as a unit in any order without any duplicates. The number of elements in which is infinite. Okay, so can you kind of guess what would that be? Can you give me an example? So one of the examples would be a set of all whole numbers. Let's say n, for example, set of all natural numbers, right? It will be 0, I think, hold on, there'll be 1, right? Is 0 natural number? Question is 0 a natural number? Yes, it is a number. Huh. Hold on. Okay, so the simple answer is sometimes yes, sometimes no. Okay, whatever. Let's say, but I thought you can't. Okay, so anyway, set of natural numbers would be an infinite set, right? For example, let's say 0 is not there. 1, 2, 3, 4, 5, right? And then it just goes to infinity. I don't know, like 1000, and then 1001, and then so on and so forth. So it's like completely infinite set. There is no border. There is no number after which you can say, okay, that's it. There is no natural number which is bigger than that. Okay, moving on. Empty set. Empty set. We usually denote it using this symbol. Hold on. Special character. Yep, this guy. So it's basically, it's kind of like a 0, which is crossed, right? Empty set. So what is empty set? Empty set is a set which is empty. It's very important. So empty set is a set which contains nothing, right? But that is still a set. So empty set and nothing are two different things. Empty set is a set which contains nothing, and nothing is nothing, not even an empty set. So those are two different things. So empty set exists, nothing doesn't really exist because there is nothing there. If your mind is exploding, just get used to that. That's what the whole class is all about. That's an empty set. I can also kind of call it like maybe denote it that way if it's simpler. Basically 2 curly braces, nothing in it. It's an empty set. The set which contains nothing. Singleton set. Right, so what is it? It's a set of one number, or like one object, right? One member, singleton set. Now, unordered pair. So what is an unordered pair? Unordered pair would be exactly the same thing. It is a set, but of only 2 objects in which the order doesn't matter. For example, P and Q. Okay. So P and Q would be, again, P and Q would be 2 letters, 2 objects. The order of them doesn't matter. Yeah, so that's why that would be a perfect example. Now, moving on, union. Okay, I'm not sure if you like took a class with Venn diagrams yet, but basically union would mean, first off, it would be represented by this symbol, kind of like a U, like a really fat U. Special character. So that would be U, right? It looks super similar to U, by the way, like at least in this font. Anyway, so U, that would be union, right? Basically, if I have, let's say I have 2 sets. Let's say I have S1, right, which is 0, 1, 2, 3, and S2, which is, let's say, 3, 4, 5, okay? Now the question would be, what is S3, which would be S1 union S2? Okay, that's usually an example I give to my students. Okay, so when you need to create a union, you need to unite 2 sets. You need to combine 2 sets into one. Keep in mind that there are no duplicates in the final set. So that's why S1 union S2 would be 0, 1, 2, 3, 4, 5, right? So although 3 is contained within both sets, it cannot be repeated. That's why 3 is only once there. Okay, moving on, intersection. Okay, like if you take that U, flip it upside down, you'll get the symbol for the intersection. Ta-da-da-da. That's intersection. Okay, so let's say I have again S1 and S2 like this, and let's say I want to create S3, which will be S1 intersection S2. Okay, so in terms of intersection, what does that mean? That means you want to find something which is in common between 2 sets. So intersection of 2 sets contains only the elements which are in common, which are contained within S1 and S2. If an element is only in S1 or an element is only in S2, that's not going to be within the intersection. So if I draw, let's say, a circle, right? So that's 1, that's 2, right? Then in this case, like the stuff over here, that's going to be an intersection, right? In our case, what do we have, like when we have S1 and S2, what do we have in common between S1 and S2? There is only one number, which is 3, right? Okay, so intersection between S1 and S2 will be 1. Okay, so intersection of 2 sets is a separate set, is a new set, which contains elements that are in both S1 and S2, which are in both first and second set. Dun, dun, dun. Cool, moving on. Okay, sequence. What is a sequence? Sequence is a list of objects, kind of, okay, it's a bit similar to a set, but not necessarily. So sequence is a list of objects in some order. In some order. Usually we denote it as like parentheses, right? Some amount of elements in parentheses separated by comma. Let's say 1, 2, 3, right? And it's very important to know that since in this case order does matter, it's very important to have the order. Then 1, 2, 3 is not the same thing as 3, 2, 1. Okay, so these two guys are not the same thing. Special characters. I don't have that symbol. Well, I have this. Okay. No, that's not that symbol. Yep. Okay. Hope it makes sense. Tuple. Tuple would be a finite sequence. Again, keep in mind that sequence can be empty, right? A sequence can be infinite, since sequence can be finite, right? So the tuple is considered to be a finite sequence, any sequence which is finite. Okay. K-tuple, which is what is a K-tuple? K-tuple would be a sequence with k elements. For example, if I say that I have a two-tuple, right? That means it is a sequence of 2 elements. If I have a 5-tuple, that means it is a sequence of 5 elements. Ordered pair, that would be a 2-tuple, right? Which means it is a finite sequence, not a set, finite sequence of 2 elements. Okay, hope it makes sense. Moving on. Cartesian product. Cartesian product, what is that? So Cartesian product of 2 sets, A and B, is another set, C, which contains all ordered pairs. Pairs. Such that the first element of a pair, of each pair, right? The first element of those pairs is an element from A, and the second element of all pairs is an element from B. Okay, so let me give you an example. So let's say we have A, right? Which has, I don't know, X, Y, right? And let's say we have set B, which contains 0, 1, right? So if I want to find C, which would be A, X, B, right? Well, not X, but the kind of multiplication of the cross. Well, it's the same X. Anyway, so A multiplied by B as a Cartesian product, it will be what? It will be, one more time, it will be a set, another set, right? That's why I put 2 curly braces. It's going to be another set which contains ordered pairs. So pairs which are 2-tuple, right? Ordered pair which is a 2-tuple, contained within a set. So basically it's going to look like this. It's going to look like just a bunch of ordered pairs. Since ordered pairs is a tuple is a sequence, that's why I denote them within the parentheses. Where the first element of each item, of each pair, is coming from A, and the second item is coming from B, which means one of the examples of ordered pairs, which will be x0, right? Why x0? Because it's an ordered pair, 2-tuple. The first element comes from A, the second element comes from B, right? And basically now we need to find all permutations. X0, x1, y0, y1. That's it. So that would be Cartesian product. Moving on. Alphabet. What is an alphabet? You probably never thought about what alphabet is. That's actually interesting because this class is kind of the mixture of linguistics and computer science. So I guess now perfect time to find out what alphabet is. Alphabet is any non-empty finite set. Okay, so what does that mean? It is a set, right? A group of objects of the same kind. It is finite, which means it's not infinite. It contains a certain amount of characters, let's say, right? 26, for example. And it's also not empty. You cannot have an alphabet which contains nothing, right? Otherwise, how can you speak or write words from that alphabet? It has to contain at least, I don't know, one symbol. Yeah, so usually we denote alphabet as sigma, right? Sigma. Okay, and again, since it is a set, we use curly braces, and for example, we can say 0, 1. Okay, so that means that this alphabet sigma contains only two symbols, 0 and 1, nothing else. That means if you kind of speak or try to write some kind of words from that alphabet, you can't really have any other symbols. You can only have words based on 0 and 1. Right, 0, 1, 1, 1, 1, 0, 0, like all, but you can't really have 2 or -1 or A, B, C, D. Okay, now what is a symbol? Symbol is a member of that alphabet. What is a string? What do you think the string is? A string over an alphabet that will be a finite sequence of symbols from that alphabet. Okay, so let's say that's our alphabet sigma 0, 1, right? What would be a string over that alphabet? We basically need to find an example of finite sequence of symbols from that alphabet. Just keep in mind that it doesn't say non-empty, right? Which means the string can actually be empty. String may contain nothing. That's allowed. That's legal. But it can't be infinite. It has to be finite. So finite, not necessarily empty or not necessarily not empty. Okay, so what would be usually the strings are denoted with omega, like this. No, like this, omega. And we usually put the quotes. And in our case, if we base a string over this alphabet, the string over this alphabet would look like, I don't know, like this. Something like that. Basically any number of symbols of zeros and ones from that alphabet, but definitely it has to be finite. Okay. Length of a string is, what is the length of a string? It's usually written like this, kind of like module, right, of omega. So would be, okay, is the number of characters in omega. Okay, so if let's say we have this string, right, 0, 1, 0, 0, 1, 1, 0, right, that would be string omega. The modulo of omega, or the length of the string omega, would be the number of characters we have there. 0, 1, oh sorry, hold on, 1, 2, 3, 4, 5, 6, 7. It's kind of like similar to the number of elements in the array, the length of the array. How many elements do you have in the array? Like 7, right? So the length of this array is 7. Okay, there's also something which is called an empty string. So that's a string, which is a sequence of elements that contains finite but 0 amount of elements, right? So it doesn't contain any elements from that alphabet at all. That empty string is usually written this way, kind of like epsilon, like this. And basically we can write it like that, right? So like 2 quote marks, nothing in between, which means it is still a string, but it contains nothing, contains no characters. And of course the length of that is 0, right? So the length of the empty string is nothing, is 0. So the length of nothing is 0. Cool. Let's stop here. I hope you guys had fun. I really love how they kind of create that artificial world of its own definitions, which is very difficult to imagine. We'll probably include some videos kind of going over that from YouTube by different people. Maybe that will help. Just trust me, this class gets complicated very quickly. So definitely, I don't want you to get lost already at the first lecture. Cool. Hope it makes sense. I'll see you guys on Monday. Don't forget about the homework due. I'll see you guys on Tuesday. Don't forget about the homework due on Monday. Please submit the notes today. See you later. Bye bye.